Good morning, good afternoon, everyone, and welcome to a new edition of Delta Lake. So we're here today with Christian Del Monte, who has been spending his day, I just learned, with something truly exciting, which is COBOL. Maybe a bit of a dated language, but we're not getting rid of it. But that's not what we're here to talk about. We're here talking about a much more recent, and I would argue much more modern project that Christian did. Delta Explain. And Delta Explain is based on a technology I'm very excited about, as we're defragmenting kind of the Delta ecosystem via Delta kernel. And aside from query engines, there's many more applications that can leverage this. Christian, you want to say a couple of words about yourself before we dive into things?
So thanks for having me, and to have the possibility to talk about Delta Explain is a great opportunity. So thank you. But yes,
Excellent.
I can start.
Yeah, then let's dive right in. Thank
Okay.
you.
So Delta Explain. So I built Delta Explain because there's always the same thing when I work with Delta Lake. A query doesn't reveal so much about the candidate set that the layout was keeping out. You know what I mean with layout? I mean simply the way in which files are saved in the object store, if they are partitioned, and in which way, which are the statistics which are collected about these files, and these are important informations because thanks to this, Delta Lake can execute already before the files are opened, can execute a kind of file pruning. File pruning that obviously reduce the costs of bytes, moving bytes around, and in the end, you're gonna pay for the execution of the query on an engine. And all this information can be found beyond the engine you are going to use. That's also interesting. Metadata is there. You just need to read it and to interpret the information inside of it to understand how Delta Lake could use this information to execute this file pruning. Obviously, these are two basic mechanisms. The first one is the data pruning, that means partition pruning. Delta Lake takes a look at the partitions, try to understand which partition you're going to use in your predicate filters if you use something, then use this information to throw away partition you don't need. No, it's just about the idea to keep what you really need in the query execution. And then second mechanism is the data skipping. Let's see what tells you our first slide. Here, there's a kind of metaphor that I mostly like. Maybe it's not the most precise, but it gives a feeling of what it happens. Now, you can imagine you are in a library and you want to find a book, I don't know, written in German, maybe by Goethe, and you know already then you don't need to look for this book in the Italian literature branch, no? Or the USR one. You go directly in the German one, and you know there are German books there, hopefully. And you don't need to look for Goethe under A or B. No, you know already, okay, maybe A and B shelves are not the right ones to find out where my book about or of Goethe is. And that's the idea a little bit. The first one is data pruning, where I'm going, in which branch of the library I'm going to visit. And the second one, data skipping, which shelves I don't need to look around, because I'm really sure there's no Goethe there around. And that's little metaphor that I think helps a little bit to understand the basics of these two mechanisms. And obviously, you could ask, why don't you use just the explain functions of functionality, possibilities of a query engine? And well, the explain shows obviously what an engine plans to do, no? But you need the engine first, and second, that's something different, because the engine does other things on the top of the information you're going to have through Delta Lake. So these are quite different things, and moreover, and you see after during this talk, Delta Explain can be also used in a CI pipeline, and gives a number. This number can be used to understand given things about the way in which data layout impacts the performance of your queries. And what happens if you change the data layout without changing the queries, for example? No, that's the most important thing. That just give a feeling of what you can do with that explain how it works. I prepared with the terminal just a brief demo. I'm going to the terminal. Okay, you see my terminal probably now. And I will say, let's see first where we are.
I think we do need to switch really quick to the terminal. 1 second. Yeah, sure. There we go.
Yeah.
Yeah.
It's dark?
Go ahead.
Okay.
Yes,
if it's
yes,
dark, mostly black, we are in the right place. Okay.
we are in the right place. and maybe to give some additional context here, because that's actually very interesting. I mean, as you said, you can just go ahead and say, okay, I don't know, explain, query, yada, yada, yada. And actually that gives you a pretty good idea of what an engine is doing. However, file skipping and file pruning, or data skipping and file pruning are kind of the opposite, right? They're things that the engine is not doing. And this is not information that a regular explain will usually give you, in the sense of, I skipped X amount of files. And maybe if you're interested, because we had this case recently, which is quite interesting, because this question comes up every now and then. Sometimes people complain and say, hey, Delta spends so much time on the metadata phase, and then the query is really, really fast. But that's exactly the point, right? So the file pruning and skipping on the large table. But sorry, I didn't want to interject. Just
it's an important point, because it's also another explanation why explain is not enough.
Yeah.
No,
exactly. And tools like yours, they can show you exactly that, right? What didn't we do? What didn't survive pruning? Yeah.
Yeah. Yeah, let's take a look to this, where we are. We are in the fixtures directory of Delta Explain. The repository contains all these files. I use them to Testable suite each time I do something, and these are just the fixtures. And they contain, level 1. They contain a lot of different ways table can be organized under the perspective of a data layout. Much of them are pretty exotic, but I would just use this users and users flat. The last two, these are pretty easy and gives us a good information. Let's tell first what are these two directors. Users are just users with properties like country, age, and they are partitioned. If we take a look to the list, for example, of users, we'll see that this table, these files are organized in 3 partitions: TA, IT, and USR. That's all. Not much to say about it. And then let's see. We execute that explain, telling which is the place where the files can be found. And in this W option, we give the count, the predicate we want to execute in our query. For example, country D and age greater than 40. We execute it and we see there's output, obviously. We see that we have a table at version 5. That means there are 4 different previous versions. And the predicate is analyzed and decomposed in 3 parts. Partition save, practically which part of this predicate we execute can be used to determine which is the partition which is relevant for us. And then another part is that save, which part of the query gives information about that can be used to utilize the statistics contained in the logs files to understand which are the files we can throw away. That's important. We don't want to know where the files, where the information is. We want to know where the information is not, because that's the most accurate thing that we can have. Obviously, statistics are pretty strange, and you want to be sure that you are not going to throw away information that you at the end really need. Then we are trying to be conservative, and that's the idea of this idea or this field, confidence conservative. These are the interesting results. Now we see that the partition pruning is throwing away already 67% of the files. That means just 2 files are remaining after the partition pruning, and the data skipping is going further. Of the 2 files which are still there, one of them is not relevant, given this age greater than 40. Let's see what happens. If we
go ahead, yeah.
with a flat table. This is a table. It's the other one, same information as you see, the same predicate. Let's call it query. And the difference is that users flat is a table which is not partitioned. There's no partition there. What happens? It happens that we see there's no partition safe element anymore. We see that partition safe is not there because there's no partition. And then the wall query, the wall filters which are in the predicate, country equal year and age greater than 40, are used in this stat safe context. The result is conservative. Only statistics are going to be used. And in the end, what is really interesting is that we have 4 files which are remaining. Here is the difference with the the previous one. Previous one we had 1 file remaining. In the second one we have 4 files remaining, and that also means that we can see how the query is the same, but the fact that data layout is different give us a different pruning at the end, and that has obviously consequences for all things coming after the pruning process, the file pruning. We have also other possibilities here. For example, we can add other options like verbose. And with this option, we see exactly which are the files we are going to be dropped and which are the ones which are kept. And maybe it's also interesting. Obviously, if you have a lot of files, maybe this view could be little bit tricky because obviously I have a lot of things. And for this reason, I also introduced a limit param option that you can use in very different ways. Obviously, there are more options. There are always with the help, we can see a lot of stuff that can be used. And as you see, you also the format JSON option. That means the output is formatted in JSON format, which is versioned, and that means that this JSON format doesn't change, can be used as kind of contract between other applications which are going to use the output of Delta Explainers tool. And another interesting thing that can be used, for example, in CI pipelines is this mean pruning. That gives you the possibility to establish a threshold. If you go over this threshold, then the tool will tell you that you are failing, will have an exit with a failure, as to say, you know, if you write mean pruning 60. Let's see, should work in this case because we have a pruning of 83, but if we go to write pruning 84, we'll see that we have an assertion failure. Total pruning is definitely lower than 84, couple of decimal lesser than 84, and that can be used actually in the CI pipelines, as I said, and as I also do in the Delta Explain repository. There are a couple of CI pipeline scripts and actions. I also published the action for the automate this step. So that's what I want to show you about the tool. Obviously, there are other possibilities. You can go back in the past. You can compare different versions to verify which was the threshold, which was the pruning percentage at version 4, which is the one at version 5, and that can be also interesting. You want to be sure that that there's not a worsening of the file pruning percentage after a new layout of the table after given changes, which can have an impact, or just change the queries you are going to execute against the data sets. That's all. Yeah.
One thing I found quite intriguing when we looked into the options, and I don't know if that's a placeholder or already functional, there was an explain why option.
Yeah,
well.
that's right. What I'm forgetting here. Explain why is actually a new feature of the version 06. It should be this one. And here, for example, it worked pretty well, and why tells you it worked all well. I didn't have problems. But let's see if I use, for example, the users flat table. The explain why also no issues. Okay. But if I do something else, let's see. Okay, always no issues at all. That's nice. I'm very happy with this.
Nice.
Okay, maybe I just need to, okay, because obviously I did all the work. Maybe I should try something else. Yeah, for example, this. And now I leave just this country here, and obviously the result is changing because country here is a statistic which is with intention distributed in a way that cannot be used properly for the data skipping in a very meaningful way. I organize the data so that the is present in all the files, let's say so. And that's why the statistics are not enough to make a pruning, and actually the files remaining are really 6. And here there's an explanation. The per file minimum ranges overlap the predicates bound. That's the reason, actually. And there are also other interesting aspects which are clarified or explain why. That's an example. There are also other, for example, if I go to use the flat just users, I don't have problems there because the data layout is once again different, and the pruning happens because of the partition save country there. Actually, just does its work now, and the pruning happens in some way. That's the idea behind it. Yeah, I also created a visual tool to make this file little bit more readable, but it's just something that you use in local if you prefer a graphic user interface. Nothing particular, just it works. You just export the whole thing here in JSON. You can use the format JSON and report. I don't know, report to, and then the file is there, and you can use it just normally loading it in this visual tool. Yeah, that's it. Then no. Do you have some questions, Roberto?
Oh, sorry. No, excellent. Very nice. Very nice. Yeah, kind of what this reminds me of in many ways, not in many ways, very directly. Ultimately, if you run Databricks, there is stuff like auto tuning, like the partition column. Well, not the partition columns, clustering columns that we use.
You mean like liquid cluster,
liquid clustering, right? So I mean, liquid clustering still requires you to kind of define which columns to use, but it's essentially a tool like this as a prerequisite. If you were to build your own platform, if you were to want to optimize kind of based on changing query behaviors, it's exactly that information kind of you want. What's the power of a specific predicate? What are the queries that users are submitting? And based on kind of the predicates they use in their queries, how should I partition my tables? And you're exactly extracting kind of the information you need for that, right? So you want to know what's the size of the files I have, but you also want to know kind of the skipping power of individual predicates within a query, because some things simply aren't very useful. An example is like binary Boolean columns are rarely useful as predicates. Anything that's so low cardinality that you're likely not going to get like AM and PM, if you have that in a time series, it's still low cardinality, but may still be powerful as a skipping predicate, because usually that's kind of time series based, and at some point it switches. You know what I mean? But other low cardinality columns usually don't have kind of a skipping power. So if you want to evaluate on your platform, how do I proceed, or you want to inform some sort of, today you might give this to an agent, or you might do some other ML on top of this, but ultimately you need this input to optimize kind of for clustering or for liquid.
That's true. And actually also liquid clustering is a little bit different, because obviously you don't have the partitioning, the classical partitioning, and the step is missing. But on the other side, you have always this statistics, and the statistics are always measured. That means the tool works on the liquid clustering without problems at all.
Yeah.
Liquid clustering is also interesting. Now you use the so-called Hilbert space curves and so, and it's different from the Morton curves, and yeah, it's really nice.
Yeah.
At some point, I will write something about it, but there's already a lot.
Yeah, yeah. And this
So
is,
missing, but
I mean, I love this kind of the embedding spaces you might use.
yeah,
Yeah,
it's fascinating, as how all
no,
these
absolutely.
theories are going to change this multidimensional way to represent data, giving you a one-dimension representation that can be then used for optimization, clustering, and whatever else. That's nice, really nice. Yeah,
Yes,
mathematics.
absolutely. Always fun.
Yeah, definitely. And well, I would go on with
With the slides, yes.
the slides, and let's see what happens. Yeah, that's more or less what I told about the way in which the whole things which reset work, and the fact that we had the 6 files of this one, just 2 stay there. We saw it already together. Just the percentage which we saw, and we already saw the small results. Let's go here, and that's this mean pruning, which I also explained before. That's interesting because you can translate, you can use that explain in the context on the SCI, and that's, for example, a use case that cannot be somehow replaced from an explain executed in a Spark UI or whatever else, because obviously you cannot copy and paste a screenshot of a Spark UI, put it in a CI, and hoping that the CI understands what you want from him. And that's a good example. And then let's see what happens. That's a little bit the way in which the tool works
I'm sorry.
now.
Just really quick, if we go back one slide, because we were just talking
Sure.
about CI and a question came in.
Mm-hmm.
So the question is, and it's definitely nuanced, but how do you test file pruning in CI without coupling the tests too tightly to the physical file layout? So I guess the broader question is kind of, how do the scenarios properly map? Kind of, do you want to test against live data in your table? Do you want to test? I don't know. Can you elaborate a little bit on that?
Yeah. Well, actually, you have always you handle always with a threshold. No, the threshold is the result that you have when you start when you use this mean pruning. Let's say 60 in this example, 60% of pruning. Things that can change are mostly to the data layout and the query you are going to execute against this data layout. 3 actually, also the pruning percentage, which are the cases where you need to change to adapt your CI scripts. Maybe you change the query, then yes, you need to also to change the way in which the script are configured. You need to rewrite this predicate for that explain so that it makes sense as test for your failure layout. Pruning, maybe the physical file layout has changed, and you can accept also a greater pruning or a lesser pruning, lower pruning than before. Maybe for you it's fine also to have 50. It's just a question of testing first in local to understand which is for you a threshold that makes sense and to adapt it. And obviously, we are working on the physical file layout. That means we are, in any case, tied to the physical file layout because we want to measure it, actually. That's we don't want the abstraction. We want to understand how this physical layout impacts our data transformation, the way in which we prune it before we go on. No? Let's say that the physical layout, what I call normally layout, is not a layout anymore, just a layout. It's kind of the part of the product. It's not just a layout. It's really part of your code if you want to see it really globally, but definitely a product, something that you want to test that need to be understood as part of your implementation in wide sense, meaning of the word. No, that's the reason why it's important to be tight, no, because we want to measure it. Obviously, we want to be there where it is.
So scenarios might be, I don't know, maybe you're generating queries in some way, shape, or form and want to see if they still retain the skipping power you have. Maybe you have compaction algorithms you're testing and you want to see that kind of the compaction still works in terms of how much am I skipping. So as you're saying, there's always a relationship between, I mean, not necessarily physical file layout, but at the very least, the min-max bounds of the data written to a file, right? So I mean, that's the thing that, and it's definitely closely tied to the actual physical layouts. Yeah,
we are always using the metadata of Delta Lake, obviously. No, we are not using the files which are there. They are related to that. We have this abstraction in between. We are using this metadata, which are obviously related to the physical layout. We don't read the files somewhere. We just work with the metadata. That's an important point. And we don't read the metadata at all. Maybe we read them in given phases, but mostly we work with delta-kernel-rs that gives us another abstraction layer which we are going to use. So we are tied conceptually to the physical layout, but we are moving on another level, no? Over the level of the metadata, which are generated by Delta Lake and which are consumed and understood by delta-kernel-rs.
Yes, absolutely.
Oh. And then, I don't know, let's see what happens after the slide. And here is maybe an important point. No, question is, where does these numbers come from? No, why should I trust these numbers? And that's the point. I'm not going to do an estimation, some statistics and things. No, I'm just going per subtraction. I execute 3 metadata scans. First, I scan the pipeline, all things which are there, as I would scan it without predicate. I have the wall. Then execute a second scan where I just take the part of the predicate that gives me the possibility to execute the partition only scanning. And then I see how many files are still there. No, those are 2. Then I re-execute the wall, always starting from the baseline with the wall query. And then I see exactly what stays there. Then I made a subtraction and I know exactly, okay, this is coming from the partition only operations, and this other one is coming from the full scan. That means one file is going to be excluded, pruned by the statistics. That's important to be understood. It's really just a file elimination. Each time I can say what is eliminated from which operation, by which operation. And the most important thing, and that I don't want to reimplement the pruning, and because in the end, this whole mechanism is already done, and it works pretty well. And that's the reason why I'm using delta-kernel-rs. No, I have already all the guarantees which are given by delta-kernel-rs. It does the real dirty work, let's call it so. No, reads the logs, use the logs to reconstruct the table, because obviously, or the abstraction that we call table, because obviously the logs are what we have. No, and then over the logs we understand what we want to take to create this thing that we call table. And so I just need to execute the right predicates against the delta-kernel-rs. I'm going to receive the information that I need to understand then how the file pruning worked. That's not interpretation really, it's really just subtraction, really very basic. And that's the reason also, this simplicity, why it's not an it's just not an assumption, it's just what it happens. And that's also the reason why I don't need to open files, because the delta-kernel-rs gives me just the independence from the file system and all of that. I'm just using it. It's a great library. It's becoming better and better. A couple of things are still missing, but obviously everything takes time it needs, and it's a lot of work to be done, and there's lots of work that was done. Really, I appreciate really the tool. Really, thank you all the team for this good work. Really, it's really important to have these libraries and so on. That's great, because without delta-kernel-rs you couldn't write a delta explain just in this way. That's just simple at the point. Now you just need to understand what you are retrieving and to use it in a proper way. It's more the idea behind it, the algorithm, what I do with these numbers, but obviously the real work is done somewhere else. That's the reality.
Well, I mean, there's layers to things, right? So I would argue this is real work, writing something like delta explain, but you don't have to redo all the work that, like a delta log replay is not trivial by any means, and not having to re-implement it is certainly helpful. And maybe since you talked about kind of these metadata only operations, a small kind of tidbit in delta-rs itself, we are looking for if we can resolve certain operations based on metadata only. And this is the case if you are querying just partition values, right? For this, we don't need to or often don't need to touch files at all. Or if you do like count sort of queries, right? So interestingly enough, some queries can be resolved based on metadata only without ever touching a file, which is obviously neat and good for performance, I guess.
yeah, definitely. And so, in any case, that's the idea behind it, the way in which that's how the statistics are calculated, and how this pruning percent is generated. Another important aspect is the way in which the software architecture is organized and the tool. No? That's also an interesting thing. The idea is that this predicate is where is parsed just once, and then with a library, an external library, and then the result is translated and converted in a own predicate AST, abstract syntax tree. That's really the AST of delta explain. Then over this AST happen different things. There are three interpreters which use this AST and convert it for their own usage. There's an analyzer which uses this information for given things. Then there's also the kernel bridge. This is the library, the part of the software which makes takes account of the communication with delta-kernel-rs, and there you see that this AST is translated in a predicate intermediate representation of delta-rs, and then there's also a last interpreter, another last consumer of this AST, which is a partition evaluator that decides what can be done, what cannot be done, because obviously there are limits in the tool. And there are a couple of things that obviously need to be understood at this point, because we have to do with SQL, which is parsed, translated, and intermediate for representation. There are things that the tool can understand and things that tool cannot understand for different reasons. And that's this boundary, this bounds is the most important thing, maybe, if you want to use the tool in a production context. First of all, let's tell shortly the end of the story. The confidence is how much can you trust, at which level can you trust the results you are receiving from that explain. You can trust them, but maybe they are always a little bit conservative. Maybe things can be better. That explain tends to be not really an optimist. Yeah, if it tells maybe I cannot calculate this stuff, then I don't do it. Just I prefer to have a file more in my results. Let's tell that pruning is not so fantastic as it should be, but I'm conservative. I don't want to promise something that cannot be kept. And that's the reason also why it's important to know what happened, how, which is the confidence of the results you are receiving. No, they are exact, all things worked properly with these different aspects. There are always problems with the false and others unknown values and so. And then obviously you have also the other side of the range, incomplete, where the predicate couldn't be understood or that could be assigned safely because of limitations in actual implementation of delta-kernel-rs, or because of the way in which delta explain translates this parsed SQL in is intermediate representation. That's important just to be said. That means also that a surviving file is not proven relevant, but it's not impossible. That's the most important thing, I think, that to take with delta explain. We prune just things that are really cannot be there. They definitely are not part of the data which are going to be kept and put on. If there's something in this gray area, in this gray space, then we take it with, just to be sure that we are not going to invent numbers which are not feasible or not realistic. It's really important, yeah. And here we come to the last point, no? The classical, what can be done, what cannot be done. And obviously there's always something to improve and so, but obviously there are limits. For example, obviously we are not opening files, no, we are just working with metadata. That means that all things coming from Parquet files, row groups, so on, are not part of the way in which delta explain can work. That means we are just working with statistics like minimum files, mean, max, nulls, total rows, things like that. Statistics which are provided by Delta Lake as a metadata format and a representation. And you cannot write arbitrary SQL expressions. The SQL expressions must be a given method, because I'm always working on the whole stuff, but obviously there are limits which are a design decision also. No? For example, you can do a lot of optimization if you want to be sure that things work. But on the other side, when you optimize a query, after a given level, this query changes form. And I don't want that the query becomes something different than the query that the user gives. And that I interpret this query in a different way than the one that, for example, the engine would do. Not that the engine optimizes, but I don't want to optimize like an engine would do, because it's not two different works. And it's important that in the end, what I'm providing is something meaningful that can be compatible with the results on the engine. That's the idea behind it. No, that's the reason why I make a step back instead of starting implementing, I don't know, conversion of ORs in ANDs and rewriting the whole things in a canonical form. That's not the idea. If I want to do something like that, I write an engine or something else. But that explain is not the place to do this. And obviously, the Morgan and such other things are there. All things which are not destructive, let's call it so, regarding the way in which the query could be translated, optimized in other places. Another thing is that the tool works just with delta only. That means if you want to use it with iceberg, it doesn't work, obviously, because I work just with Delta Lake. And
yeah. I mean,
where we are
Delta
now.
5 and Iceberg v4 are coming, and at that point, actually, the file level metadata is equivalent with the what's called the adaptive metadata tree. So, at some point in a future release of Delta kernel, you might just be able to do this for Iceberg tables too.
Okay, there's always something new to do. That's also nice with tools like this. It's an open end. I like it. And
Yes.
yeah, there's other ideas, and obviously there's other things. For example, deletion vectors. Deletion vectors are not part of the idea. They work in a different way, and obviously they compromise the way in which that explain would interpret the files. But nice thing of that explain, it tells, oh, look at that. There are deletion vectors here. Maybe what I'm telling you couldn't be right because you have deletion vectors activated in your table. So statistic maybe are not the right ones and things like that. There are a couple of mechanisms which I inserted to be sure that that promises which are done are kept. So I already said.
Yeah. I mean, you're touching on some very interesting points because, I mean, ultimately, there is a bunch of rewriting of queries happening, and actually the Delta protocol gives you an out because file skipping by definition is always best effort, right? So as you said, we can only skip files where we can guarantee that there is no data matching the predicate. But in many cases, this guarantee is kind of one-sided, right? So if we can't prove that, doesn't mean that there is data. There still might be no data that matches the predicate. And deletion vectors essentially just, in quotation marks, make your stats inexact, right? Because you may have deleted the min or the max value.
Right.
So your bounds from what usually are tight bounds on your files become upper and lower bounds that may or may not have a corresponding value in the data. So file skipping and rewriting expressions in terms of min-max values is also non-trivial, right? So you can't apply the filter age equal or age larger than 40. You have to now rewrite this to max value smaller or equal to 40 in order to get kind of a predicate on your stats, right? And yeah, you don't have to go into all of this. This is some of the stuff that delta kernel takes away from you. You don't have to.
Yeah.
Do
I
all
just
of this
wait that the kernel gives me the APIs, and then
and you mentioned null values. Null values, I think, are, well, I don't want to say kind of the most common source of error, but if you never dealt with it, null treatment in SQL might become surprising. Like, I don't know, there is no equality. Null is not equal to null, as you might expect. If you just look at kind of the code, null equals null should always be false, which is interesting SQL null semantics. And handling all of this kind of stuff is, yeah, non-trivial to get that right. But yeah, as you say, and this also limits kind of how arbitrary SQL expressions, delta kernel obviously doesn't support all of this. But there is this thing called opaque expressions, but we're going deep into engine territory now.
Yes, really interesting. Definitely interesting. Yeah.
Yes.
And then after this slide comes probably the last one.
Right now it's loading.
But I know in the last one there's nothing. So it's just yeah, it's just last sentence. Query engines explain what the plan execute, and then that explain asks for an early question. And this earlier question, as we saw, I think it's really important to be answered. And the answer is, I was really surprised to see that it's not really a tool that gives you already this answer. That's also a reason why I wrote that explain, because I was really surprised. I said, why I cannot have this information? Just I thought maybe it's something there. But so I hope this, yeah, make this gap.
So this is
smaller.
This is kind of a very interesting point you're mentioning, because on one hand, you can't get this information easily. On the other hand, literally every engine that supports Delta kind of needs to go through those motions, but it's always kind of hidden inside. And while Delta kernel is meant to be embedded, it is certainly also exposing a lot of the logic. In fact, there is kind of a new API being worked on, which is based on logical plans, but it's it exposes some of this by encapsulating it, because that information is gathered, or a lot of this information is gathered within every engine. We do have another question. So Christian, just tell me if you want to take that question. I think it's not quite explain related. So will Parquet v2 introduced in recent times? Is there any pattern changes for predicate pushdown or file pruning? I don't know, Christian, do you want to take this, or I can field that question as well if you want?
You can filter it out. I think it's not so related to that explain. I think maybe I need to know.
No, it's not directly delta explain related.
It's also interesting as question, but please.
So there is a high-level question and a lower-level question. So file pruning, I think, is not directly affected by Parquet v2. And here I have to qualify my answer a little bit because I'm not entirely sure about everything that went into that. I think mostly this is encodings. So how does data get encoded? And there is different kinds of encodings like run length encoding, different ways how data can physically represented in compressed forms. Right, one of the most popular ones is dictionary encoding for categorical columns. Rather than storing a bunch of strings, you store a dictionary of strings to integers, and then the actual physical data is just integers, which obviously is much, much smaller on disk size and in memory size than if you were to store this as kind of fully expanded strings, right? And another interesting thing is if you do transformations, you can also just transform your data in the dictionary rather than actually transforming the orders of magnitude larger size data in your arrays. So will it make changes to predicate pushdown? So this gets interesting now because predicates get pushed down into the Parquet read, and there are encodings that allow you to do skipping. And here we're not talking about file skipping, we're talking about page skipping.
That's right, but there's always the engine that
exactly
drives these operations. That's something that's done, for example, over catalysts in Spark, and so there's a logical plan, and then you use the Parquet radar to give this push down filter to Parquet, and then the reader does the work on the physical level, but obviously there's something that happens somewhere else in the engine.
Exactly, and this is a very important point. So are there any changes? This is engine territory. Each query engine can decide how to implement the actual physical Parquet scan and optimize away to their heart's content. So V2 makes a bunch of stuff, a bunch more, can be much more performant, but not always. And it's a deliberate design choice that delta-kernel does not interfere with those decisions. It gives an engine the freedom to optimize away. It doesn't constrain that decision, but that is what kernel considers engine responsibility. It doesn't do I/O. It doesn't do any of this.
Yeah.
I hope that answered the question. It's stuff I get passionate about as well. Christian, we're about running out of time.
Okay.
Is there some last words you want to share with the community out there?
I want just to tell that the tool is open source. Everyone can help making it better. And if you want to know more about it, I wrote a couple of articles and the repository is pretty informative. There are documentation. Really, if there are follow-up questions, you can find me by emails and so on. And thank you a lot for this possibility also, once again. Thanks.
Very, very happy. You can also find Christian in the Delta Slack and bother him there. Also feel free to bother me and reach out. Maybe we can drop a link in the comments as well to your repository if people want to check it out. Thank you so much, Christian. Awesome work. Have a great day. And thanks again for being with us this morning and afternoon.
And evening.